Well, everyone, I am back with part 4 of this video on attempting to repair the Tektronix 576 curve tracer, and this may be the last video on this series. Unfortunately, I had a bit of a mishap while I was working on it, and it's broke beyond repair. So I'm going to have to just part it out, the parts that still work, and sell it on eBay. But let's take a look at the damage. Uh, I'm just kidding. Check it out. We have steps. Got a BJT NPN transistor on it. And we've got curves. It's working. All right. So check that out. How cool is that? Yeah. So it is working, it looks like. And for this video, I'm going to go over, a couple of the things that I did between now and the last video I did to see what likely fixed the problem. It's really potentially really stupid on my part. I'm going to be kicking myself for not looking at this earlier if it is the case, but there may have been something else too that was having an effect. And we'll go over both of those things really quick. And then I'm going to put the thing back together and then run through the performance and calibration checks again. So again, I'm not going to go over every single step. There's already a YouTuber by the name of Zen Wizard Studios who does the calibration, the full calibration of this. And he's much more knowledgeable about these than I am. Definitely would be the better video to watch if you want to learn about calibrating these. But what I am going to do is probably just stop and record when we find areas on that either need an adjustment, or although this is working, there may still be some issues with the calibration or some other things that I haven't discovered quite yet. I know the looping on this guy is really bad, and so I'll go into some detail about that, and maybe putting it back together will help to resolve that. But we'll see when we get to that step as well. But yeah, I think that's what the plan is, and hopefully this will be the last video in this series. But off to a great start. All right, let's get started. All right, so I've got the thing mostly back together, and I just wanted to show you guys a couple things before I move forward with the performance checks and calibration. So this is why I said earlier I was going to be kicking myself, because, well, first, I forgot to mention, for those who haven't seen the other videos, in the previous video, we going through the performance checks, and we pretty much determined that there has to be an issue with the step generator amplifier for this thing. Showed that the step generator appears to be working, but through the performance checks, we just weren't getting, it didn't seem that the step generator amplifier was working. In the first video I did, I put a transistor on the test fixture, and we weren't getting any curves, no steps, no different a series of curves. So it appeared that there was an issue there. So after I did that video, I went on to the EV blog forum, and also TechScopes, which is a groups.io forum for Tektronix users, and a user by the name of John said I should probably look at the harmonica connectors, which are these guys right here. They kind of look like harmonicas. And this J360 is the connector that connects to the test fixture. Okay, so it wasn't loose on this end. I mean, I made sure of that because I took this guy out to bypass the high voltage interlock and also fix the terminal selector switch. And I was pretty sure that I had, you know, had checked to make sure these were tight as well. But when I took a look most recently, this one screw on the left side, I think it was the left. It was one of them. One was tight and one wasn't. But anyway, yeah, it was definitely the left side. Was very loose, and you could push the whole connector all the way in on one side, which means that anytime I was putting this test fixture in, it was probably pushing this whole connector back and maybe not making a secure enough connection. So that could have definitely been the problem. Now I went back and when I found that, I tightened it back up. It was a real pain in the ass to do that. I was able to do it without removing the collector supply, this entire unit here, because in order to do that, I would have to have disconnected these couplers to the switches. I mean, it would have been a real pain. So I did have the whole thing flipped over, and I was able to kind of move a portion of it out of the way. There's a transformer here for the collector supply that is connected via these little plastic pieces, which are actually cracked. A few of them are, but anyway, I was able to disconnect that and then kind of shift it out of the way just so I could get my hand in there deep enough to retighten that screw. But anyway, that could have been the problem the whole time. Now, there was another thing that could potentially have been the problem as well. So this is the step generator board, obviously, and you know, after I did the third video, I was really at a loss for where to go next. So I just started testing all of the transistors on this board individually. I did the same for the transistors on that heatsink behind that board. Removed them from circuit, tested them out of circuit. They were all testing fine. And the same goes for these little transistors as well. Now, there was one transistor that is, I don't know if you guys can see it because I put this piece back on, this part of the chassis. But there is a transistor, here, let me get my flashlight. Sorry about that. But yeah, transistor Q, oh geez, oh here it is. Transistor Q226. You know, when I was removing that guy from circuit to test it, yeah, it's that tall guy right there. That's actually the brand new one. So, when I was removing that guy from circuit to test it, it appeared to have tested fine, but you know, I had to kind of move the leads a little bit to get my test leads on there, and then I had to bend them back into place so they would fit into the socket properly. Well, one of the leads ended up breaking, and I think it was a 2N3904 or something like that. I didn't have that on hand, but it's very similar to the MPS 2222A. I think the 2222A is a bit more robust. It can handle a greater drain current, but yeah, so I just popped one of those in. And yeah, so that transistor is involved in the plus one amplifier, which makes up the greater step generator amplifier. We can show you guys where it is on the schematic. You know, it's that guy right there. You can see it plays a pretty critical role in the output amplifier. Its collectors right attaches directly to R224, which I believe is used for adjusting the amplifier balance So it definitely plays a critical role. Could that have been a faulty one and replacing it resolved the issue? Possibly. I think it's more likely that connector being the problem, but it was just something else that I wanted to point out. Um, so yeah, now that I've got the whole thing back together, um, removed all the tape that I had on all those wires for the low voltage board and rectifier board. Um, but yeah, now that I have the whole thing back together, pretty much, uh, I think we can start the performance and calibration procedure all over again. And again, I'm not going to walk through every single step, but I'll stop and record at spots where, you know, um, either we're now seeing the correct results when we weren't, or other areas where we're still not getting what we should be getting. So that's what I'll do next, and we'll see what happens. Okay, so I actually just got done doing all of the low voltage and high voltage accuracy tests, and for ripple, everything looks great, nothing has changed. And then right after that test, they have you check a couple of the horizontal and vertical switch accuracies. So for the horizontal, they ask you to check settings 5, 2, and 1. And then for the vertical, 5 milliamps, 2 milliamps, and 1 milliamp. That's actually what we're checking right now. And you can see this is what we have on the multimeter, well within spec for that setting. It's plus or minus 0.00125. So, yep, we just got done checking all those and everything looks good. On to the next step. So after the voltage and ripple accuracy checks, it then starts to have you check the geometry of the trace, both on the horizontal and the vertical. Right now we're looking at the vertical, and this looks really good. You're looking for any bowing of the line, or is it crossing the center radical, and you do the same for the horizontal. Everything looks good. Now when I first went through the performance checks in the third video, although I didn't show this, during those checks I actually made some adjustments here, and everything still looks good, but I just wanted to show you that because we didn't go over that last time. Looks good. Alright, so we've gotten to another step here that we might have a problem with, and that's adjusting the horizontal and vertical CRT gain. So, you know, it has you starting off with the setting it in NPN mode, and then, you know, from there it has you bring the trace to the center gradical using the fine position controls, and then it says to switch it over to PNP, and it says that you should be within plus or minus 0.01 divisions of the 10th horizontal and vertical radicals, which should be right here. And the trace goes completely off the CRT screen. So now it does say you can adjust these pots, vertical output and horizontal output gain pots, but adjusting them doesn't bring the trace onto the screen. So I'm not sure if this is a problem yet or not, but you know, as I move through the checks, we'll see what happens. But just something to notate. I can't remember if it was like this for when I did the checks the first time around, but you know, we'll see. Alright, so here's another step that we, well, I think this is the first step that we encountered in the performance check that we couldn't perform the first time because of the fact that the step generator amplifier was not working. And likely due to the poor connection to the standard test fixture, but now we have a transistor, I believe it's a 2N 55 5550, 2N 5550, because you need a transistor with an emitter, uh, yes, a collector emitter voltage of at least 50 volts. So that guy is much higher than that, and this is what we are getting on the display. So this looks very similar to the example given in the service manual. Now, it looks like what we have is a bit closer to the first one. So you can see each step, the traces look a little bit elongated, whereas I guess they should be more of a fine point for each step when you're... See, we're in the pulse step mode. Okay, so that automatically puts it in DC mode, so we really should only be seeing a fine point and not these long traces. I guess that's what they're getting at here. Now, the adjustment for this, let's see. So this is adjusting the horizontal compensation. So the adjustment for this guy is adjusting the trimmer capacitor C433, and that's actually under this that little panel right there. So we need to remove that, and then we'll be able to access that trimmer cap and see if we can get something a little bit closer to the service manual. Now I'm going to do that now, and then let's see what we get. Alright, so this was the best that I could get it. I have removed the cover. There it is. It's a nice little air variable capacitor. You can see the plates meshed between one another, and then you can, adjust them in the other direction. That'll move the plates away from one another, so you're increasing the separation between them, and that'll change the capacitance. But yeah, that's the best I was able to get it. I don't know if this also has something to do with the looping, which that gets checked at the end of the calibration procedure, so maybe that'll improve that if with some adjustment there. But yep, that's the best I can get it, at least with that adjustment right there. Alright, so now we're on to step 15, which is just a check, not a calibration. But one thing I've noticed, and we kind of saw this issue before when switching to PNP, is that the trace is not exactly where it should be. So for PNP, it should be right here. Okay, that's where the 10th vertical and 10th horizontal graticals meet. And you can see it's a little bit further off. Almost if this was the 11th, that would, that is where it's kind of sitting at. And I guess it's correct for the vertical. It's at the 10th, but not the horizontal. So, and you can get it there by adjusting the fine position control a bit, but this is for when they are centered, and it clearly is having some issues there. So, and again, you can switch to PNP now. That's correct. Or MPN, I'm sorry, that's MPN, that's correct, that's where it should be. But for PNP, it's a little bit off. So I don't see a step in the procedure yet, if there's a way to adjust that, if there is, or what that is, could be a symptom of. But just something I wanted to notate as we're moving through this. And yeah, I just wanted to show you guys this as well for the from the manual. This is kind of giving an overview of where the trace should show up, depending on what settings you have And you can see for PNP, normal should be right there, and we're a little bit off. So, yeah. Okay, so kind of going with what I was saying earlier about the positioning of the PNP trace. So now this procedure is asking us to kind of check the positioning controls to make sure they're accurate. And so if we, for the vertical switching, you should be seeing 5 divisions each time it's changed. So we moved 5 divisions, 1 turn of the switch, then another 5. That looks good. Now for the vertical, you can see, so we've kind of 1, 2, 3, 4, 5, almost 5.5. And then, you know, it's now where it should be for NPN, but it's almost as if it's kind of, if we're starting all the way out here, how's it getting to where it should be for the NPN position? So I don't know if that's an indication of something with, you know, the vertical, I mean the horizontal gain knob potentially, or some other issue that needs to be, adjustment that needs to be made, but just wanted to notate that as well. Yeah, and so again, it has you set it to in an NPN, doing the same test. Yeah, it's still off, but not for the vertical. The vertical looks good, so I'm not sure what adjustment needs to be made there, but definitely something is off. Okay, so this is another step that we weren't able to perform, or at least get the correct results of. This is checking the center line value switch accuracy. So when we did this the first time in my third video, we weren't able to do it, but now you can see clearly on the meter we've got 1 volt, and we are getting that voltage using the offset multiplier switch. Also, we've confirmed that the center line value switch is accurate. We have it set to 1. The trace is centered on the CRT radical, and we have 1 volt on the meter. And so I'm going to do that for each setting of the center line switch, and make sure that we have it's accurate for each setting. Okay, so now we're checking the accuracy of the horizontal switch, which again we couldn't do correctly in the third video I did, and you can see here we're centered on the CRT radical, got 5 volts on the meter, and we have the amplitude set to 0.5, collector is set to 0.5 volts, and I'm just going based off this table that's provided in the service manual. So you're gonna check all those up to 2 volts, and I should get the correct voltage on the meter. And so far so good, we're looking very accurate, and I'm going to continue with this procedure and keep moving forward after that. And again, we're still on that same step, and what I should just shown is actually checking the collector voltage. And so now it's asking us to do the base, so from 0.05 to 2. So I'm at 0.05, and again we're going to be adjusting that together on the amplitude switch as well. So starting at 0.05, the trace is at the center on the CRT radical, and so we have 0.5. volts, which is what we should be getting for 0.05. And I'll just show you guys, you know, a quick. So here it's not really requiring us to do much adjustment at all. So, and again, you're using the offset multiplier switch to make that adjustment, and you can see it's bang on at 1 volt, and that is what we should be getting. So for 0.1 volts for the base, 1 volt. So everything's looking good as far as accuracy for the horizontal switch, and the fact that we're able to do it with the offset multiplier switch, you know, which wasn't working before, and the reason for that is just because that's adding or subtracting voltage or current from the step generator output. So there you go. Okay, so now we're checking the vertical switch accuracy using the Deca box and my DC multimeter, and you can kind of see that, you know, it's the same principle as I've showed you for the horizontal. So you're centering the in this case, instead of the vertical gradical being centered on the vertical center gradical, it's the horizontal center gradical that you're centering the trace on, and you can see we're a little bit off here. Now, at first I was thinking, well, maybe there's an issue with the instrument, but there is a footnote in the service manual that says if you're using a DC voltmeter with input impedance of less than 500 mega ohms, so this meter clearly has an input impedance less than 500 mega ohms. I think it's 10 mega ohms, like a lot of meters are. So that could explain why we're the difference that we're seeing. So we have 5 volts. 5 volts, it should be centered for the 5 microamp setting of the switch. They do give a formula that you can use to calculate that error, and I guess I can give that a try. I'm a little bit curious to see, so why don't I do that, and let's see what we get. Okay, so when I do that calculation that is in the manual, so you would do so for example, for the 5 microamp setting of the switch using a 100,000 ohm or 100k ohm resistor, DC voltmeter should be reading 5. So for that setting, V1 is equal to 5, and then you multiply that by Rm, which is the input impedance of that meter. So I put 10 mega ohms and divided that by 10 mega ohms plus 10 kilo ohms, and I got 4.950. And now I've centered it, and my meter's reading 4.954. So this calculation works out pretty well, and looks like we'd only have to do this for the 100k and 10k resistors to get a better idea of the accuracy. So don't have to do it for everyone, just the higher ohm resistors. But alright. Okay, so moving on through the vertical switch accuracy testing, we move down to a lower resistor, 1 kilo ohm. So for that, the voltage readings on the multimeter start to get a little bit more accurate. And so, for example, I'm checking the 0.5 milliamp setting, so I should be getting 5 volts with the 1 kilo ohm resistor across the collector and base input. So, and you can see on the display the trace is a little bit off the center gradical, but there is a spec. It's plus or minus 0.4 divisions. I don't know how they measure 0.4, but you know, 0.4 if you're just close to 0.5, and the trace is clearly within point plus or minus 0.5 division, so it's still within the spec, which is good. And again, that inaccuracy could still be due to the difference in impedance with the multimeters. It's gonna not have an effect as big an effect, and I'm basing that off that calculation they gave as the resistance drops. But yeah, I think it could be that, and also the decabox, the resistors in there should be fairly accurate. I think they're more accurate than the resistors that the service manual suggests that you use. Now, I did order some resistors of the exact specs that the service manual notates. They just haven't come in yet, so I figured I'd use the decabox. And plus, this this doesn't involve any adjustments of any kind. It's just a check. So I figured I would just use that to see what we're dealing with. But there you go. Alright, so now it's asking to check the vertical switch for accuracy in the emitter range. So setting that mode to leakage for emitter current. And then I've got a 2.5 mega ohm resistor. This is the only precision resistor that I have that matches the specs that the service manual asks for. So again, it gives you another one of these nice tables. And so for the vertical switch at 10 nanoamps on the 10th horizontal radical line, if you move the trace to that line, you should be seeing 0.5 volts on the meter, and we are. So again, the vertical switch is looking accurate, getting the readings that we should. But yeah. Okay, so now we moved on to the step generator adjustments, and I looked through step 20, adjust the zero crossing and step delay. Everything looked good there. And now on to step 21, adjusting the zero step level. This was another step that gave us issues the last time we tried it. The trace would just completely disappear from the screen, or it wasn't there at all. And now it's centered on the center gradical as it should be. It will require no adjustment. If it's not, you should make an adjustment at R224, the amp balance adjustment. So yeah, we're looking good there. Okay, so we just got to another step that required a bit of an adjustment. As soon as I finished saying that this step required no adjustment, you switch the amplitude switch from 0.05 to 2. The trace should be horizontally, it should be centered on the CRT radical, and it was all the way out there. So it actually has drifted a little bit, but by adjusting R97, you can bring it to the center. It's a very finicky pot. It will, just the slightest adjustment will move it fairly far. So I'm gonna have to play with that a little bit more, but just wanted to notate that. Okay, so that did require a bit of adjustment, but looks like it's not drifting, or not nearly as bad as it was when switching from the range of the amplitude switch from 0.05 to 2. Might require just a little bit more playing around with it, but you're just making Um, Going back and forth between the pot's R97 when you have it set to 2 volts, and then R224 right down there when it's set to 0.05, and you're just trying to get that zero offset adjustment. Is that, yep, zero step level, I'm sorry. So I think we've got that dialed in, but I might play with it a little bit longer. Okay, so here we have another step of the zero step level adjustment that needs to be corrected. So this is actually after making those adjustments with R97 and R224. It asks you to put the instrument, press the polarity invert switch, and the trace should be still on the center, the CRT gradicle should be centered on there, and it's clearly not. And so now it is asking to adjust the R127 invert zero adjustment. So let's give that a try. I assume that is also on the step generator board. Yep, I see it right there. So yeah, see, these pots are really finicky. Yep, this is, I'm gonna try a different screwdriver. These pots, you don't need them to be, you don't need an insulated screwdriver to adjust them. Oh man. Yeah. Yep. Okay, I think that's, yeah, that's better. Okay, so I think that is now all of the adjustments for the zero step level adjustment. I think we're good. Now on to the step amplifier gain. Okay, so I just finished up the step amplifier gain, and actually all of these settings within this step were okay. They had a quote-unquote wide range. It could be plus or minus 2 divisions. All of them are around this CRT, the center CRT gradicle, so that's where the trace should be. So it could be somewhere within 2 divisions that way or 2 divisions that way. I still made an adjustment anyway for each to get it right on the center, but everything was looking good in that respect. And so now we can move on to the current balance, see what happens with that. Okay, so this is the last part of the current balance adjustment step, and this is another step that actually don't require any adjustment on my part, so this is the last part. So it's having us put an 18 kilo ohm resistor between the step generator output and the base, and then connecting a 1 kilo ohm resistor between the base and the emitter. And so that the trace, this is actually the 10th spot of the of a step in a positive going increasing steps. If we let's see if we can, yeah, there you go. Okay, so we're actually looking at that guy at the top there. Yeah, he should be centered on the CRT gradicle. and it is. Otherwise, we'd have to adjust R243. So that's looking really good. And yes, we can move on. Okay, so now we moved back onto some checks. So this is the step generator, well, the offset multiplier accuracy check. And so you are just, after putting in some settings to the 576, you're just checking the accuracy of this offset multiplier knob. So, so it should, every time you switch to a, by one full switch, so not point 1, point 2, or point 3, and so on and so forth. It has to be from 1 to 2 to 3, or or the reverse. So for example, right now we're set to 1. If we go to 2, we should see the trace still on the center CRT gradical. So again, I'm going to turn this guy to 3. Okay, so it actually has you start at 10 and then go down to 0. And so I've already checked this switch almost throughout its entire range. Okay, so there's 1. Alright, so yeah, so this guy appears to be accurate. So that's good, and I think next will be the amplitude switch accuracy. Okay, so now we are at this step, which checking the accuracy of the step generator. Well, this is the amplitude switch. So, when we got to this step in the last video, we kind of knew that we weren't going to be able to test this. But now we are looking really good. So I'm going to just show you guys, starting with 0.05 volt setting of the amplitude switch. So that should correspond to 0.5 volts plus or minus 0.01, and we are looking really good. So just gonna go to 0.1, 1 volt plus or minus 0.02, again great. 0.2 volts, we should be seeing 2 volts on the meter, plus or minus 0.04, also good. 0.5 volts should be 5 volts on the meter, plus or minus 0.1, very good. 1 volt on the switch, 10 volts on the meter, plus or minus 0.2 volts, again really good. And finally, 2 volts on the switch, 20 volts on the meter. It's negative. I must have the leads switched, but you get the idea. It's plus or minus 0.4 volts, and again we are looking great. So the amplitude switch for the volt settings is looking great. Now in order to do that for the current settings, again you'll have to use the Deca box, which I won't be able to do for all of these. The Deca box can only get up to 100 kilo ohms, so still need those resistors that I purchased that haven't come in yet to do the 1 mega ohm setting. And again, these need to be precision resistors, not just any resistor will do to do these checks. But yeah, so let's maybe go through those, the ones that we can, and see what we get. Also, again, real quick, the same equation, they have a footnote here that we were using to do the vertical switch. That also applies here as well for the higher, I guess for the higher resistors like the 10K and the 100K. We'll have to do that little formula due to the impedance of our meter not matching whatever meter they used. But here we go. Alright, so I've just been going through the current settings for the amplitude switch, and everything looks really good. Now, I started at 1 ohm. For some reason, the readings just aren't very accurate at 1 ohm on the Deca box, and I noticed that as well when trying to use the 1 ohm decade for a different measurement for the vertical switch. So might not be, it may not be as accurate as the other decades, or there might be something wrong with that decade, but the other ones look really good. So I did using the 10 ohm resistor, the 100 ohm resistor, and now I believe I'm at the yeah, I did the 1K and now at 10K. So if we look here for 10K, so that's starting at let's see, is it, am I at 10? Yeah, I'm at 10K. So starting at 20, yeah, 20 microamps. So we should be getting 2 volts. 2 volts plus or minus 0.04. That looks good. 10 microamps. Getting 1 volt plus or minus 0.02. Also looking very good. And then for 5 microamps, we should be getting 0.05 volts at plus or minus 0.01. So also looking very good. So the amplitude switch is looking good as far as accuracy. Again, this was something we couldn't test in the last video, but it's looking great this time around. Okay, so I'm on step 28 of the performance checks, and it's just at this point in the procedure it asks you to hook up a oscilloscope to the step generator output and ground connections. So I just have a BNC connector that is an adapter to these this dual line connection, and that's basically what the manual asks you to do. So it's just obviously you're gonna have to change your attenuation to 1x, which is what I did, and so yeah, it just has you take a look at some of the step generator buttons. And so one thing that I found interesting though, and I wish they would give an example waveform for this, because things do look good. So right now I have the rate set to normal, and I just have it set to number of steps to 1, and so you can see that looks good on the display, and then also on the oscilloscope that looks good as well. And so that's just 1 step, and it's at a frequency of 60 hertz, and that's because this the 576, the step generator sweeps at the line frequency. So whatever your line frequency is, that's what it's going to be sweeping at the normal rate. Now, if I hit the 0.5 button, it slows it down, and so we're looking at 30 hertz on the display. That's all good. Then we can double it, and we get the same here as well. So that all looks good. Gonna switch it back to normal, and we can even see what happens when we do some of the pulsed steps settings. So 300 microseconds. So you can see it's changed a lot. And so what's good about this feature is if you want to test at higher current or voltages, and you don't want to do damage to the component you're testing, it's good to use these features because it's sweeping it at a different rate, and you're getting, and the overall voltage is decreased. So we can try 80 now, and you can see it's even less now on the display. So that is all looking good. Let's go back to steps. But this is what I am a little bit unsure of. So I'm going to increase the steps and keep the um, camera on the oscilloscope. So we're at 1. Okay, that's 2. That's 3. 4. 5. Okay. Let's just fix the scale. Here. Okay, let's keep going. 6, 7, 8, 9, and 10. Okay, so this is the one thing I'm not sure about. Is that how that's supposed to look? You know, or is that not right? I'm not sure. So I'd be curious to know if anyone has any input on that. I'll have to maybe look at the service manual, see if I can find if there is a example waveform for the step generator output. But yeah, that just doesn't. I don't know, something. I don't have an explanation for why, but it just looks a little funky to me. But I just thought I'd share that. But everything else looks good. You know, as far as the sweep rate, that's correct. So, and that might be right. That might be right too. I just don't know. I just thought it was interesting to share. Okay, so now we're on to adjusting the looping compensation. Now the looping compensation or looping, this looping is an artifact that's intrinsic of the instrument. It's caused by unwanted stray capacitance that is due to some components within the instrument, such as the guard box and the collector transformer, and this capacitance is transferred to the chassis ground, but it's also picked up by the vertical amplifier of the instrument. And the service manual tries to go in depth on how this is caused, and I still don't completely understand it, but it basically shows itself as a loop on the instrument, on the display. It's not a loop now because it only shows up as a loop when you're sweeping the collector supply in the normal mode. So now it's in DC mode and it just shows up as kind of like a straight line. And right now I'm in the part of the procedure where you can adjust the length of the vertical line using a combination of the trimmer capacitor C301 and the looping compensation knob, which they're both, again, air variable capacitors. And you can see let me see if I can show you guys. I might need a flashlight. Yeah, you can. Let me see. You guys can see. Yeah, maybe not, but you can kind of see, maybe, if you know what an air variable capacitor looks like, the plates behind these switches, and that's a big air variable capacitor, and it just runs the length of the instrument and connects to the shaft of that loop compensation knob right there. And so these trimmer capacitors here are also air variable capacitors, much smaller ones though. But this is the shortest I could get the width of that vertical line. That's the best I could do. I feel like while watching Zen's video, he was able to get it much shorter. So, there might be something else going on here with the instrument that needs to be fixed. But, we'll see how the rest of the calibration goes. Okay, and now it's asking you to make pretty much the same adjustment, or it's the same idea, except now we are at we've had the max peak volts knob set to 350 and 1500. And so I just got done making that adjustment. This is the best I could get it for both settings, and you're using instead of C301, you're adjusting C339. And you can't get, for example, if I could have gotten 350 even smaller, but then it would have make the 1500 one larger. So you got to find it somewhere in the middle, to get the shortest for both settings. So again, I feel like in Zen's video, he was looking at a much smaller line, but this is the best that I can get right now. Okay, so this is another step in the loop compensation adjustment, and we've switched now from DC mode to normal mode. So now you've got the collector sweeping with a rectified sine wave, and now you're seeing a loop, a huge circle, and for this, now the directions for this are a little bit, I really don't even understand them completely. It says for this guy, let's see, yeah, so okay, set the max peak volt switch to 1500 and then mode switch to norm. Okay, so we've done that. And then it says check for trace with minimum deviation from the horizontal line at start of sweep. Okay. So minimum deviation from the horizontal line at the start of the sweep. I'm not really quite sure what they mean by that. Are they talking about the center horizontal line, which would be here? Maybe. But anyway, for this guy, it goes on to say, well, if you need to make that adjustment, adjust C341, which is the noise rejection adjustment, for a minimum deviation of line. Typical setting is of 341 is almost fully counterclockwise. Yeah, so this, and then it also adds high voltage will appear on this capacitor. So be careful when you're adjusting C341. Again, I use my insulated screwdrivers to make these adjustments. Yeah, so that guy is turned fully counterclockwise. Adjusting the loop compensation on the front. Oh, well, there you go. Okay. So that brought that way down. Yeah. Alright. So maybe that's all I needed to do. But yeah, I'm still not quite sure what they mean by that. Minimum deviation from the horizontal. Again, I assume they mean maybe the center? Maybe? That's really the only thing I can think of. But when you're doing this, you want, the service manual talks about this in a few different areas of the manual. And my understanding is the smaller the loop you can make it, the better. So I'm going to go with that setting. I'm going to go with that adjustment. And yeah, let's just keep going forward. Okay, so this is actually the last step of the calibration procedure. It's having us look at the looping compensation for each of the max peak voltage settings. So I'm at 15, and then we'll just go back up so we can take a look at each of them. And it's going to have you, make adjustments using the loop compensation knob. Um, but I think we've got it. Yeah, that actually looks really good. So that's for 15, and then you're gonna also be changing the horizontal collector volt, the horizontal volts per division. So for each setting, and there's a table in the manual. So for 15, which is what we're at 2. So let's go up to 75. So I'm gonna change that to 10. Okay, we're gonna bring this up to 75. Okay, let's see. Okay, and I'm going to assume this is kind of like some of the other adjustments where you can't get one perfect, the other ones will go out of whack. You got to get somewhere in the middle for all of them. So we'll see what effect that change has on the others. But yeah, let's go up to 350. So that's gonna have you set the collector to 50. I mean the horizontal switch to 50 volts per division, and 350. Okay. Yeah. Yep. Yep. All right. Let's do a 200, 1500. So that setting it to 200. Yeah. Yep. Yep. All right. So let's go back down. All right. Yeah, let's see. Let's do 75, and then 15. Yeah. Yeah, I think we're gonna leave it like that. Um, yeah, because when I tried to bring these even in the lower voltages, even in better, it threw the 1500 way out of whack. So I think that's good. Let's take another look at the 1500 again. Yeah. Yep, I'm gonna leave it there. Yep. Alright, well, actually, the looping didn't look as bad as it had when I tried this before I fixed the step generator amplifier, which again was probably just due to that J360 connector being loose. I can't believe that. But yeah, because what was interesting, the not only was there a loop, but the trace had a sinusoidal. Um, it was very interesting. I'll have to draw it out on a piece of paper, because that has clearly gone away. Um, Give me 1 second. Got a pen here. Yeah, it was very interesting. It looked something like this. Yeah, it looked like that. Very odd. So clearly, we are not seeing that anymore. And I think that looks better. I think that's closer to normal. Um, you know. But yeah, if anybody has any comments on what that should look like, if it still looks poor, please let me know in the comments. But yeah, that concludes the calibration procedure. Now, to just a reminder, there still appears to be some issue with the where the PNP is, where the trace is positioned when it's in PNP. So we were doing some testing earlier where it seemed that the horizontal switching was inaccurate, and so I'm going to go back and take a look at those steps again, make sure I had all the settings correct, and you know, if I find anything different, you know, we'll record it, and you know, we'll kind of go from there. This video is started. I don't want to make another hour and a half long video, so I think we're getting close to an hour. So I might stop it. This might not be the last video actually, but yeah. So let's do that, and yeah. All right, so I went back into the calibration procedure, and I went back to the step 8, which is the adjusting the display amplifiers, adjusting the balance of the horizontal and the vertical display amplifier. So I went through and redid that, and then adjusted the horizontal and vertical CRT gain using these pots right here on the chassis, and I think we got it to a much more suitable setting. So this is where NPN should be at the 0, where both the vertical and horizontal 0 radicals meet. I was getting tired of flipping to the example graph in the service manual, because I kept forgetting the notations for each of the radicals, and so I just wrote them on the instrument until I can memorize them. But anyway, yeah, so that's where the vertical and horizontal 0 radicals meet, right down there for NPN, and then PNP should be where the 10th vertical and horizontal radicals meet, which is right in that corner there. And so you can see, switching to PNP, we are there. Now it gives you plus or minus 0.01 divisions. Again, you know, I don't know how you come up with that. That's a very qualitative measurement. I mean, I guess you have divisions here. So how many is that? 1, 2, 3, 4, 5. Okay, so you've got 5 divisions within each division. So that would help you with, you know, like 20% or 0.2. But yeah, so I mean, I think the center of that is within 0.01 divisions, and going back to NPN, I think the same is true there. So, you know, it just took a little bit of adjustments with the with some of the trimmer pots, but I think we've got it. I'm gonna go through and just make sure some more of those procedures, and I'll find anything else wrong, I'll record it, but I think we're good here for now. Alright, so this step is actually adjusting the vertical display amplifier gain, but it can also, you know, it also can tell you a little bit about the horizontal amplifiers as well, to make sure they are calibrated correctly. So for example, now just pressing the 0 button, that is where the trace should be on the 0 vertical gradical and the center horizontal gradical, and then pressing the cal button should bring it all the way to the 10th vertical gradical. So yep, we should see it here. Now if the horizontal was off like it was earlier, that spot would either be, you know, a little bit ahead of the, you know, it would be off the 10th vertical radical, either left or right of it, and it was for me until I made some additional adjustments. So that's looking good. It's also looking good for the vertical um, gain as well. Um, the vertical display amplifier gain. That's looking good. That's trace should be centered on the horizontal um, center radical. So compare 0 and yep, so that looks good. And then they just ask you to do that throughout for a few of the settings of the vertical switch. So you do it, bring it to 0.2. Looks great. And then 0.5 milliamps, I'm sorry. Okay. All right. Yeah, so this is looking really good now. I think we've got that issue fixed with where the trace was located when switching to PNP. And again, it had something to do with the horizontal amplifier gain being off, or balance being off in some way, but it looks like we've fixed that. Okay, this was another step that I just wanted to take another quick look at again, because you know, with this the max peak volts knob, the this little plastic piece, it's broke, so sometimes it can be difficult for me to actually make sure I'm setting it in the correct position. I have to go all the way to the 220 watts uh, position, and then work backwards from there, count how many times, because it's just, yeah, I need to glue that back, but it's easy to, for me at least, to accidentally put it in the wrong position. And the positioning for this knob is critical for this test in ensuring that you get a series of curves that match up to what the service manual has. And while I am still getting these little tails at the end, it looks a lot better than it did before after making some adjustments. But yeah, I just wanted to point that one out as well. Alright, so I've actually, gone back and looked over all of the first portion of the performance check calibration procedure, and got all the way up to step 23, which is adjusting the current balance. That step looked great, by the way. And if you're doing the adjust steps only, go on to step 32. Step 32 is the loop compensation, which we just did not long ago. So I think this means we are good to go as far as the calibration goes. We were able to fix the PNP and NPN positioning by doing some of adjustments with the vertical and horizontal display amplifier. So yeah, those are my only concerns. Even the looping looks a lot better now as well. So I think the instrument electronically is good to go. Now, there's still some things I'd like to fix, like this this max peak volts knob. Just gonna glue that back together. But I think that's it for the most part. I mean, I guess what I can do right now is just kind of go over a quick recap of what we did to the instrument. So again, and these are in my other videos, starting with the standard test fixture. We disabled the high voltage interlock. This again is a instrument, at least it has to be from the mid 80s based on its serial number, and some of the ICs have a date code from the mid 80s. So its high voltage interlock utilizes a photo micro sensor. I don't know if the older ones used that type of sensor, but that's what this one did. So I disabled it, and if you want to know how to do that, or at least know what I did to do that, that's in video number 1. There was a blown resistor on the terminal selector switch, a 22 ohm resistor that I also replaced. And so once those things were done, and obviously we weren't getting, in my first video I wasn't seeing any, wasn't able to test a transistor. So I started looking at other areas of the instrument, checked the power supply, found that all the voltage rails were low. It turned out to be capacitor C707, which is one of these big capacitors. So I replaced that, gutted the original and put a modern one in there, and so I could still keep the solder lugs. So once that was fixed, all the voltages came into spec after adjusting the trimmer pot on the low voltage regulator board. And then from there, wasted a lot of time, apparently, trying to figure out what was wrong with the step generator amplifier. But it was most likely, it was most likely that J360 connector being loose. So that's actually what I ended up fixing as well. That connector was loose on the instrument side, on the chassis, so I tightened it up. And then, I'm still not ruling out whether or not this had an effect, but transistor, I don't think you can see it at this angle. Oh yeah, there it is. It's right there by that dual transistor or FET. Yeah, that guy right down there. That's transistor Q226, so I replaced that only because when I took it out I accidentally broke a lead off of it. But yeah, it seemed to be working fine before I broke it, so I'm going with the loose connector there. And but yeah, once that was fixed, the step generator started working again. In this video, we ran through the performance checks and calibration again, and everything is looking pretty good. Maybe the looping might be a little bit too much. It's hard to say because the service manual doesn't provide any examples of what it should look like. It provides one example, but not within the calibration procedure as to what it should look like. And the descriptions are vague, but I think we're looking really good. I think that's looking good. If someone who knows a lot more about these sees it and can maybe comment and say otherwise, that'd be great. But yeah, I think we're good there. And that really wraps everything up. I mean, I do have some precision resistors coming in so I can check the accuracy of the the vertical and amplitude switches, but I'd still like to do that. I don't know if I will do another video on that, but what I would like to maybe do is, after I get to play with this instrument around a little bit more, is do a video maybe testing a few different components, like different transistors, NPN, PNP, BJTs versus MOSFETs, and really get an idea of what this instrument is capable of. But I'd like to play around with it first before I do that, because I still don't fully grasp all of this thing's capabilities and the different types of testing it can do. I'll still need to read through the manual to get a better idea of that, but I think we can wrap it up here. I mean, so yeah, I think that's a wrap. This has been a lot of fun working on this guy, but I'm just as excited to get started with doing some component testing with it now that it actually works. So yeah, let me know what you guys think. Leave it in the comments. If you want to see some of the other repairing that I did on this guy, you can watch the other videos. I know they're longer than they need to be, but hopefully somebody finds them helpful. But until next time, I'll see you guys later. Alright. All back together. Yep. And of course, I have leftover screws. Shit.